first we are going to talk about the chemical test for the presence of water. So there are two chemical tests. We are going to talk about both of them. So we can test for the presence of water with the help of two compounds, which are anhydrous copper sulfate, which is CuSO4. This is white in color. So all the pure substances have a sharp and exact accurate value of their melting and boiling. Now let's talk about where do we get water from, why is water used, and what are the beneficial or what are the harmful. So before we dive into this chapter, let's first look at all the topics which we are going to cover in this particular video. So first we are going to talk about the chemical test for the presence of water. So there are two chemical tests. We are going to talk about both of them. Then we are going to talk about the purity of water. How do we test if the water sample which we have is pure or not, and what is distilled water. Then substances in water from natural sources. Then we are going to talk about beneficial and harmful substances which are present in the water. Then the water treatment. Okay, so I hope you are ready to dive into this chapter because this is going to be very exciting. First, let's talk about chemical test for water. So we can test for the presence of water with the help of two compounds, which are cobalt chloride and another one is your copper sulfate. First, let's check the first method, which is when we are using cobalt chloride. So we use a cobalt chloride paper which is of blue color. Okay, COCl2, which is your blue color. When we add it or dip it into the water, then the color changes to pink. Okay, so when we are dipping it into the water and the color changes, it means the water is present. Now, why does that happen? What is the chemistry behind that? So when COCl2 is added to water, it forms COCl2.6H2O, okay, which is pink in color, and therefore the color changes, and hence it can be used as a chemical test for the presence of water. Now let's read anhydrous copper chloride. Anhydrous meaning without any water. Initially it is blue in color, and then hydrated copper chloride, which is COCl2.6H2O, which is pink in color. So anhydrous cobalt chloride can be used to test for the water. This test is usually done with cobalt chloride paper. As I told you, this is blue in color, and when it changes the color to pink, this becomes your COCl2.6H2O, which is hydrated copper chloride, which is pink in color, right? So the presence of water causes a color change from blue to pink. Next, we can also use copper sulfate. Okay, other than your cobalt chloride, we can also use your copper sulfate. Now what happens here? This is the second method to test the presence of water. The anhydrous copper sulfate, which is CuSO4, this is white in color, and when we dip this into the water, then the color changes to blue. Okay, why? Because CuSO4.5H2O, which is your hydrous copper sulfate, that is formed. Okay, this is the reaction, and therefore because the color changes when we add it into the water, it can be used as one of the tests to check the presence of your water, right? So these are the two tests. If you wish to note down them, you can do that. Next, let's move on to your purity of water. Now, how do we check if the water sample which we have is pure or not? So all the pure substances have a sharp and exact accurate value of their melting and boiling point. Okay, so when we check their melting and boiling point and they come accurately what is written in the data, then we can say that those substances are pure. But if the melting or boiling point value is different from the accurate value, then we can say that some impurities are present there. So pure substance boils and melts at specific and sharp temperature. For example, your boiling point of water is 100 degrees Celsius, we know that, and the melting point of your pure water is your 0 degrees Celsius. Right, now what happens when impurities are present? It will increase the boiling point. Okay, so when impurities are present, it will increase the boiling point. So your boiling point will be above 100 degrees Celsius and the melting point will decrease. Okay, so impurities tend to decrease the melting point, and hence we can say when there is discrepancy in the values of your melting point and boiling point of any substance, then we can say that that particular substance is not pure, right? Next is what is distilled water. Now, why do we need to talk about distilled water? Because whenever we are doing any test in your labs, then we use distilled water, not tap water. Why? Because in tap water impurities are present, but in distilled water impurities are not present. Okay, distilled water is pure form of water. So what happens, we take water and we boil it, the water vapors we collect, and those water vapors are condensed to get liquid. So that liquid is deprived of all the impurities, and hence it is said that it is the pure form of. Now let's read. Distilled water is water that has been heated to form water vapor. First it is converted into vapor and then it is condensed back to a liquid. So now the liquid which we are getting, that is pure. Okay. So this means that it contains very few impurities. Distilled water is used in practical chemistry because of its high purity. Why we are not using tap water? Again, because it contains impurity and we do not want any hindrance in our test. Okay, any interference or any hindrance in the test. Hence we use pure water as a solvent. Tap water is not typically used because it contains more impurities which could interfere with chemical reactions. Now please note down these important points. Okay, now let's talk about where do we get water from, why is water used, and what are the beneficial or what are the harmful things which are present in water. Okay, so we use water in many aspects of our everyday life. For example, your domestic use, your agricultural use, or industrial use. So for drinking, cooking, gardening, general sanitation, you're drinking for animals and watering crops, as a solvent, as a coolant, and heated to make steam used to generate electricity. All of these uses are of water. Okay, so water is very important for us. It is very useful. Now, where do we get water from? Water is found in natural sources such as lakes, rivers, underground water, which is your groundwater. Okay, next, a rock or rocks which store water are known as your aquifer. Okay, water from natural sources may contain variety of different substances. Those substances can be dissolved oxygen, which is beneficial to us. Then some salts like calcium, potassium, sodium, and magnesium. Okay, these are also very important to us. Then plastics, which are harmful. Then sewage, which are harmful. Then harmful microbes. Then nitrates and phosphates from fertilizers and detergents. Again, they are very harmful. Okay, now many of these substances enter water sources when rain falls and washes them into lakes, rivers, or groundwater. Some of these substances are naturally occurring, but many are direct result of human activities. Now let's look at the beneficial or harmful substances which are present in water in detail. So some beneficial substance, as I told you, is dissolved oxygen, which is essential for your aquatic animals which are present. Then metal compounds such as calcium, magnesium, sodium, okay, and your potassium. These are some important and beneficial metal ions. Then your harmful substances include metal compounds such as your mercury, lead, or aluminium. These are very harmful. Okay, next are some plastics. If plastics are present, then they can get trapped in plastic waste, like the animals can get trapped in plastic waste, dying of starvation as their stomach is filled with plastic. So it is not at all good. Okay, so it is a harmful substance. Next is your sewage, contains harmful microbes which can cause diseases. Then nitrates and phosphates that are present because of the presence of fertilizers. Okay, so now let's check how do we treat water, how do we get clean and pure water which are fine with the purpose of drinking. Okay, so untreated water contains soluble and insoluble impurities. What are some insoluble properties or insoluble compounds which are present in your water? They include soil, pieces of plants, and other organic matter. Some soluble impurities include dissolved calcium, metallic compounds, and inorganic pollutants. Right, now let's talk about the whole process, and this is going to be the diagram which will explain us how water is treated, okay, before we get the water in our taps for drinking purposes. So the first step is water, okay, that from the water the large insoluble substance such as your rocks or your plastic is removed, okay, through screening process. So the first step is your screening process, the step in which it is removed. The large insoluble objects such as rock, plastic bags, and branches is removed, that known as screening process. The water is then taken to a sedimentation tank. Okay, after this what happens? The second step is your sedimentation tank, in which what happens? The sedimentation tank, the soil and sand will drop at the bottom of the tank. This is what sedimentation is, right? When the heavy substance like soil and sand gets settled at the bottom and the water is above that. Right, this is how it is separated. So the second step is clear, the first step is clear, screening and then sedimentation. So look here, this is your screening process, screens for straining floating rubbish, and then storage reservoir where we add a small amount of ozone for disinfectant of water. Before that, what do? Sedimentation process. After this, what happens? The next step, let's say this is the third step. The next step is the process is to filter the water to remove smaller insoluble particles such as soil or sand. Okay, now the water is often passed through a very fine sand to filter out these particles. This is your third step. This rapid gravity sand filters. Here the small insoluble particles like soil or sand is removed. Okay, next what happens? Water may contain dissolved organic compound that can cause the water to have unwanted odor or taste. So what do? We add activated carbon filter. This becomes your fourth point. We add activated carbon filter, which is here. Activated carbon granules or filters absorb some of the chemicals which are responsible for the bad odor or taste of the water. Right, this is your fourth step. Now after this, what happens? Before water is distributed to homes, the final step. This is your fifth step. The final step is disinfection. Okay, so what do? We add chlorine to it. Around 2 to 3 mg per dm cube of chlorine is added as a disinfectant before the water is distributed to our homes. Okay, so this disinfectant is needed as it is helpful to kill harmful waterborne microbes such as bacteria that can cause diseases. Different countries use different methods, but the most common and effective method is by adding small amount of chlorine to the water. Typically chlorine is added to a concentration of 2 to 3 mg per dm. Okay, because even chlorine gas is very toxic, so we have to make sure that the chlorine which is added is proper concentration. So around 2 to 3 mg per dm cube is used. A summary of the main stages involved in the water treatment is shown in the figure, which is this one. Okay, now clear. First step is what? Your screening, wherein the insoluble big substance like plastic, rocks are removed. Then sedimentation is the second step. Then the third step is when rapid gravity sand filters, where we remove the insoluble small particles such as soil or your sand. Then the fourth step is adding activated carbon granules so that they absorb some of the chemicals which are responsible for the bad taste or odor in the water. Then the fifth step is to add the chlorine. Okay, why? Because chlorine acts as a disinfectant. So when we add this, it can kill the harmful microbes or the bacteria which can cause diseases, right? And then it is then distributed at our homes. So this is the complete process during water treatment. Okay, so you can note down this. Okay, so now we can end this video here so that we can come again and meet in the part 2 of your chemistry of environment really soon. If you have any doubt, feel free to comment down below and I'll get back to you. And stay tuned, part 2 is coming really soon. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.